So in this video, I am going to be talking about parallel and perpendicular lines. Now before we do actually get into the proper calculations of how to find a line that is parallel to another line or a line that is perpendicular to another line, we'll first get into the basics. So first of all, we need to dissect what y is equal to mx plus c is. M is the gradient and C is the y-intercept. Now it's the y-intercept is basically its coordinates is 0 and this is y. Like it varies in different equations. Now it's kind of common sense because when you replace x with 0, you will always get this number over here, and that number is the y-intercept. So not the y-intercept but the value of y, and that's why it's that's why c is equal to the y-intercept. So now to the definitions of parallel and perpendicular. Okay, so parallel lines are, or two lines are parallel if they keep on going forever without intersecting, and in order for them to have that, they must have the same gradients but different y-intercept. If they have the same gradient, same y-intercept, that means they're coincident. They are the same lines and they overlap each other. So example of parallel lines would be like this. These two lines, they keep on going without touching, and in order to represent that they're parallel, they would usually be given something like that, like that. And then perpendicular is a little more complicated, but not as much. So perpendicular, wait, let's perfect that. Okay, perpendicular lines are lines that when they intersect, they form a 90-degree angle. So like when they intersect like this is equal to 90 degrees. Now in order for that to happen, they must have their gradients must multiply in order to get -1. So like if there are two equations, y is equal to 1 over 2x plus 3, y is equal to let's say -2x plus 4. These two gradients, when they're multiplied, they do give -1, so therefore they are perpendicular over here. So they're basically parallel and perpendicular. They depend on the gradients. In parallel, the gradient of the first line must equal to the gradient of the second line. Well, in perpendicular, the gradient of the first line must multiply with the gradient of the second line to give -1. Now on to the calculations. So I'll give you one question about parallel, one question about perpendicular, and then we'll stop there. So let's go for parallel first. You have line A. Line A lies on 2 points, 0, 6, 1, 7. Line B lies on one point, which is 0, 3. And these two lines are parallel. Find the equation of line B. In order to find the equation of line B, we depend on line A, because with line A we can find the gradient. We can also find the y-intercept without even doing any calculation, which I'll show you how. And by the gradient, you will find out line B and the y-intercept of line B. So the formula for the gradient is y2 over y1, y2 over y1 over x2 over x1, and x1 is this thing over here, or let's just x1 is this, the 0 in, or yeah, okay, so this is x1. Let me just write it a little bigger. this is x1, this is y1, this is x2, this is y2. Okay, so when you do that, you get 7 minus 6, y2 minus y1, 7 minus 6, over x2 minus x1, which is y1 minus 0, which is 1 over 1, which is 1. Therefore, line A is equal to y is equal to x plus c. We don't have to put the 1 in front of the x. So now for c, the calculation is needed. As I told you, the y-intercept is 0, 6, and the c is the y, or the y coordinate on the y-intercept of the y-intercept. As you can see, 0, 6, so it is a y-intercept. The line A's y-intercept is 0 and 6, and you add the y coordinate to line A, which basically means y is equal to x plus 6. This is not needed in this case. We just need to move on into line B. Now we have the gradient of line A. We know line B, because they're parallel, also has the same line, so y is equal to x plus c. Again, same thing, they provided us with information that B lies on a point called point 0 and 3. 0 and 3. Since x is equal to 0 and y is a non-zero number, or it is like, yeah, it's a non-zero number, therefore it's a y-intercept, and you take the non-zero number, which is the 3, and you add it, and therefore line B is equal to y is equal to x plus 3. Yeah, it's 3. Yeah, and there we go. So that's a typical question which you can get about this parallel. Now let's move on to perpendicular. Okay, so perpendicular. Let's say you have a line, let's call it line C. It lies on 2 points again. Or let's make this a little different. It lies on, or the equation of the line is y is equal to half x. The equation is line of the line is half x. Line D lies on, or lies on one of the points, which is 2, 3. Find the equation of line D. And line C and line D are perpendicular. Find the equation of line D. Now again, as I told you, this over here is, we need to know, it's very crucial. So we have m1, which is 1 over 2, the gradient of line C. Multiply that with m2, which we don't know, so we'll just label that D, line D is, which is equal to -1. You multiply both sides by 2, and you get D is equal to -2. Therefore you have line D is y is equal to -2x plus c. Now in order to find c, we substitute 2 and 3 with y and x. So that will be y is 3, -2 times x, which is 2, plus c. That will be c plus minus 4 to -2 times 2. I just flipped the equation around. -2 times 2 is 4, is equal to 3. So c is equal to 7. Therefore, the equation of line D is y is equal to -2x plus 7. Now on a graph, this would usually look something like this. So we have this, and then you have this line which intersects, and that is the 90-degree angle. So just quick reminder again, remember m1 is equal to m2, and m1 multiplied by m2 is equal to -1. So that's the end of this video. I hope you guys enjoyed it. Please do like, share, subscribe, and comment. And then I'll see you tomorrow. Goodbye.